Welcome back to another lesson. Today's learning goal is I can use the point slope formula. This is a continuation of what we've been doing already, and we're going to be applying it to graphs more. So, real quickly, remember that this is the point slope formula, where this is the y value and this is the x value of one point on the line, and this is the slope. M is the slope. So, here we have y minus 5 equals 1/3 x minus 3. Okay. Remember that this means that we have a point of 3, 5, because it's 3 minus 3 equals 0, and 5 minus 5 equals 0. So we're going to have a point 3, 5, and we're asked to list a point and a slope. So 3, 5, let's put a graph of that right here. Okay. And the slope, again, is this number right here. So our slope is 1/3, a positive 1/3, which means that we're going to go over 3 up 1. And then we're also going to go backwards like this. Okay, which gets us this line right here. And we could also, if we wanted to, convert this into slope-intercept form. That would be y minus 5 equals 1/3 x minus 1, then add 5 to both sides. We would get y equals 1/3 x plus 4, and we can see that our y-intercept is in fact 4, and the slope is 1/3. So remember that the slope-intercept form can give us the slope and the intercept, while the point slope form will give us just a point and the slope. Question number 2. Go ahead and try that one out on your own. From the formula, we can tell that there's a -1, -3 is on the line, and it has a slope of -2. And because of that, we can graph this line. We can also change it into slope-intercept form. And when we do that, we find that it's y equals -2x minus 5. And so we did it correctly. It says Gavin needs to write an equation for the graph below in point slope form. In A, list the information Gavin needs to write his equation. So here, we're going to take this point right here, 5, 7. Okay, and we can see the slope is -3, because every single time we go over 1, we go down 3, so our slope is -3. Using that information, we can do y minus 7 equals -3 x minus 5. Okay, and then we're going to rewrite this in slope-intercept form. So what that becomes is y minus 7 equals -3x plus 15. We're going to add 7 to both sides. And what we get is y equals -3x plus 12. And again, the information we get, well, the last one was point slope, so we got 1 point and the slope from that equation. But here we get the slope-intercept, so we get the y-intercept inside this, which is 0, 12. Okay. In questions 4 and 5, write an equation for each graph in this point slope form, then rewrite it in slope-intercept form. Okay. There's many ways we can do this. Here, let's just use, what point can we use? Well, there's really, I guess there's this one right here. Go ahead and use that point and create the point slope in slope-intercept form of this line. What you should have found is that this is y plus 3 equals -3 halves x plus 2, and if we distribute that and move the 3 to the other side, we get -3 over 2x minus 6, which means our y-intercept would be -6, which we can see that if we were to continue this line, it'd go right there. On number 5, go ahead and use, let's do this point right here to create your point slope. What you should have found is that using that point that we got was y minus 6 equals 6x minus 3. And if we were to distribute and move this minus 6 to the other side, we get 6x minus 12. This one says, use your knowledge of point slope form to find the y-intercept of the graphed line. So here the y-intercept is a little bit ambiguous, but we know we have a point 3, 1 over here. So use this point to create a point slope equation and then transfer it into a slope-intercept to find our y-intercept. Go ahead and try that on your own. What you should have found is that the slope was 1/2, and y minus 1 equals 1/2 x minus 3 turns into y equals 1/2 x minus 0.5, which gets us a y-intercept of 0, negative 0.5.